Okay, this is CSU Pueblo Physics 202 Lab Charge to Mass Ratio Experiment. So what we have here is we have electrons that are accelerated in a uniform magnetic field. Now, at the beginning, we have Q times the potential, electric potential voltage. Now this is our potential energy, and this is our kinetic energy. So this is an example of conservation of energy. And from this equation we can solve for the velocity. And this is voltage and velocity, just to clarify. The charge of the electron, mass of the electron in this equation. Now once this electron is accelerated in a magnetic field, the magnetic field will produce a force on the electron, causing it to rotate in a circular pattern. And so we can assume that that is a centripetal force, which is equal to the magnetic force on the electron. Now this is a cross product, vector cross product, so that means the direction of the electron, the magnetic force, and the magnetic field vectors are all perpendicular to each other. And its motion is determined by the right-hand rule. So this magnetic field, as written here, is coming out of the board in this diagram. So it's a three-dimensional picture we're looking at. Now from the magnetic force and centripetal force, we can go through the math and solve for Q over m, which is the charge of the electron and the mass of the electron. So that's why this lab's called the charge to mass ratio. And this is our voltage applied, and this is the radius of our electron motion, and B is the strength of the magnetic field in Teslas, which is based on the type of coils in our diagram, which we will look at next.